Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
So the third rule, name the compound starting with the less dominant substituent group, then followed by the word benzene, and then followed by the nomenclature of, by the name of what? By the name, I think that this is contradiction. By the name of what? Of the most dominant substituent group. So this means that the summary of this rule is this. Here we have the name of less dominant. So when you say less dominant, the smallest, okay, less dominant. The least dominant substituent group. So here we start with the name of what? Of the less dominant substituent group. And actually for this series, halogens is the least dominant substituent group. While methanoic it's the most substituent group, followed by what? Sulfonic acid, right? So this is the least substituent group, least dominant substituent group, followed by this one, followed by this one, followed by this one, followed by this one, followed by carbon and compounds, followed by derivatives of what? Of carboxylic, followed by cyan, then followed by amine or amino, we call it amino, then followed by sulfonic acid, followed by what? Methanoic acid. If you go in opposite directions, you go from methanoic to halogens. This is most dominant substituent group, right? Most of the substituent group is called methanoic, sulfonic acid. This is called what? Amide. This is a functional group of amide. This is called cyan. This is called what? Derivatives of carboxylic acid. This is called the carbonyl compound. This is called the amine or amino group or amino substituent group. This is called the alcohol or hydroxyl. Okay, so simply this is called as hydroxyl. This is called the hydrocarbons. For example, methyl, acyl, propyl, butyl are in this category. Okay? Then this is what? Nitro. It's what? Nitrogen. No, nitro compounds. Can we call nitro compounds? Okay, yes, we call it nitro compound in terms of organic, but actually this is nitrogen dioxide. And this is representing what? Halogens. Bromine, chlorine, iodine, fluorine, you find them in this category. Are we together? Okay. So you have to remember these rules. So let us solve problems by using that rule. And then, so okay, I didn't finish this one. So at the beginnings of the name of this of the nomenclature for the carbons or for the benzene with more than one substituent group and has a dominant group, the first part of the name will be the name of the less dominant substituent group, then followed by what? The word benzene. So the word benzene will not be at the end, it will be at the middle. Then followed by what? The name of 40 of most substituting most what? Most dominant. Most what? Dominant. Substituent what? Substituent group. Most dominant what? Substituent group. Which I have already recommended here. The most dominant group in the given series are methanoic acid and sulfonic acid. So if a compound has either methanoic acid or sulfonic acid, you have to name it by following this rule or this order. Are we together? This is the simplifications of the information in online. So ladies and gentlemen, let me present to you example 6. Name the following. Name the following aromatic organic compounds. So make acid. This is so this here you can take a warning to write concept. So the structure of benzene can be written in this way. Remember that we are using a digital teaching system. We call it a active learning system. Active learning system. So active learning system means that the student is center of the process of learning. So, first of all, okay, we have to cross-check our organic compounds, aromatic organic compounds. Okay, we see something. So, we have to remember the rules. The first rule says that what? Identify the most dominant substituent group present in the aromatic compound. Stop writing, stop copying. That's the first rule. The second rule, once you determine it, you have to number the carbon atom, starting with the carbon atom that carries the most dominant substituent group. What does this mean? You remember that in case of alkane, especially in case of unsaturated hydrocarbons, alkene and alkyne, right? For example, if you have chosen the longest parent chain, okay, usually you have two options, whether to number from left to right or from right to left. But you have to look the positions of double bond or triple bond. So the best way, or the rules that state, you have always to number from the side. It means you have to start numbering the carbon atom from the side where the double bond is near to the end. Are we together? So these rules mean that it guides us how we can number 6 carbons of benzene. The preference, the first priority, where the most dominant substantive group has attached. So the carbon which formulated the covalent bond between the most dominant substantive group and the carbon atom, it's the one that we are going to number it in number 1. At the rule. That's why I told you, you have to be careful in nomenclature of benzene or aromatic compounds. Okay, so here it is the business. So that's the second rule. So we're numbering the carbon atom starting with what the carbons that carries on the most dominant group. And then I mentioned the most dominant group in this series that can help you are methanoic and sulfonic acid. This is what you have to look. So it means that if you find that the compound does not have methanoic acid or that does have neither methanoic acid nor sulfonic acid, don't think that the amide will be maybe the another next most dominant group. No. According to the literature, these are the only 2 most dominant substantive group. Okay? So it's simple for you to remember. The second rule, after we number the carbon's atom, we name the compound starting with less dominant substantive group, then followed by the word benzene, and then followed by the name of what? Most dominant substantive group. Are we together? So we want to apply these 3 rules of nomenclature of benzene with more than 1 substantive group by solving example 6. So name the following aromatic compounds. These are the aromatic compounds that we have. So I've given you Roman 1 to 40 to 3. So I want to name only 3 aromatic compounds and leave 1 at the homework for you. And if I love you too much, I could ask you that which one should I give for you? And I know always the simplest.
The first one.
Okay, no, I didn't ask you. Solution. Solution. So you have Roman 1. So let us start. Always, whenever Olenjolai teaches you, he used to teach you from the simplest concept. We get into the medium difficult concept, and then we get into the complexity concept, that the algorithm or process of learning. If you do vice versa, you get confused rather than be helped. Okay? So we hana simple question, we hana moderate difficult questions, we hana difficult questions. So let us start with Roman 1. So Roman 1, the first rule, ask identify what? The most dominant group. Do you have any most dominant group?
Yes.
What is its name?
Methanoic.
Methanoic acid. That's the first rule. So you've already identified it. The second rule, we have to number what? Carbon atoms in benzene, starting from what? The carbon that carries what? The most dominant substantive group. So where is it? This one. So when we number, we have 2 directions. Whether to go this way or whether to go this way. Right?
Yeah.
So listen carefully. So if you go back to the rules of naming hydrocarbons, if you have, let's say, 2 attached group in the same ring or in the same organic compounds, always you prefer to, it means that you prefer to number from the carbons where those 2 substantive groups are nearby. What does it mean? If I number this carbon 1, 2, 3, 4, 5, this is substantive group, we'll take number 5. If a number in this direction is 1, 2, 3, so it means that this the right or this the correct directions, because this the one of the attached group, but we do have also another attached group, and this the side where it is nearby. Are we together? So that's another rule. That now, because these rules, they just tell us or they just teach us where should we start to number. So don't think that we don't apply other rules that we learned in alkane, alkene, or alkynes. So if you find you have two less substantive group, then you have to remember the concepts of naming them alphabetically. Are we together? Okay, thank you. So this is 1, 2, 3. You can keep on 4, 5, 6. Okay? So we follow the rules. So we have numbered. That's the second rule, right? The third rule. Now let us name the compound starting with less dominant group. How many less dominant group do you have? Only one, which is methyl. Okay? And then followed by the name of benzene. Aha. So where is that less dominant substantive group of methyl attached? It has been attached in the third carbon of benzene, right? So write this methyl what? Benzene. Okay? Then we name what our most substantive group, which name is what? Methanoic acid. So methanoic acid. This is the simplest question compared to the rest. That's why we give it Roman 1. Just to ask you, welcome to the nomenclature. Some students, they want to swallow the mobile phone when they are watching the video. That's how advanced life it is. A teacher gets tired, students get tired. So we say that it's balanced equation. Okay, we go from 1 2. The first rule, identify the presence of what? Identify what is most dominant substantive group in the given aromatic compound. Do we have substantive group here?
Yes, we have.
What its name?
Sulfonic acid.
First your part. Sulfonic acid. We got the second rule. We have to number the carbon, right? Starting from where? The carbon, which carries what? Less, yeah? Congratulations. Most substantive group.
Yes.
Okay, so if that's the case, again here we have two alternatives. Either to number 1, 2, 3, or number 1, 2, 3. So now we come. These are halogens, so most of them are listed substantive group. At least dominant substantive group. So there we have to follow the previous rule that we taught you of in naming more than one substantive groups attached in the hydrocarbons, and we have to follow the rule we call it. You can name them alphabetically. So the one that starts in alphabet is the one that will take the less number of carbon or of numbering. Okay? If we number this 1, 2, 3, 4, 5. I want my students to understand. So it means that this is chloro. Chloro starts with the letter C. And this is bromo. Bromo starts with the letter B. So it will have number 5. So alphabetically, we have A, B, C. So B starts before C. So this is not correct, because why are we numbering and why should we make this decision? In order to make all the students who have been given this question to have the same answer. Otherwise, we'll have two answers there. Are we together? So for that case, you agree with me. I have convinced you that this is the first carbon, this will be the second carbon, third carbon, fourth carbon, fifth carbon. And this is the sixth carbon, if you need it. Okay. So what the name now? So we have 3 bromo hyphen, then you have 45 chloro. These are the names of 40 less dominant substantive group. That's what we apply in the third rule. Okay? Then followed by the name what? Benzene. Then followed by the name of 40 substantive group. Sulfur, sulfonic. Sulfonic what? Sulfonic acid. You're done. I know that because I'm guiding you. I'm the one who is thinking. I'm the one who is actually trying my level best to make sure that I do this and that. You might, so you can realize, this nomenclature are simple. Because I'm the one who is just guiding and holding the chalk and thinking. You are receiving. But they're not simple the way you think. Okay, ladies and gentlemen, so if that's the case now, so if that's the case, okay, I feel in my heart, this should be 0.4. Roman 3, we can try now. Then let us go to Roman 4. So Roman 3, this is lefty as your homework, 4, 04. Will you do it, Francis? Okay, Francis tells me that he will do if God wishes. Okay, so now here we are. The first rule, identify what? The most dominant substantive group. Do you have most dominant substantive group here? The answer is yes. What is name? Methanoic acid. The second rule, we have to number the carbons. From where? From there. Or starting from where? Starting from the carbon that carry most substantive group. Towards where? Towards where we have a nearby less dominant substantive group, or towards the directions where we have a substantive group which is starting alphabetically. So we have 2 routes here, right? We have 2 routes. This is first the carbon. Remember, this is 2, 3, 4, 5, 6, 7. This is fluoro. This is the S side. So how can you go there? What should you take consideration? Because when we are numbering this substantive group also, we check the possibility of interaction between the substantive group. We really prefer to number by following the directions where the substantive group are closer, because some other, for example, hydrogen bond can be developed there, which can strengthen the bond. Okay? Yeah. So for this case, listen carefully. We have 2 options. Number 1, 2, 3, 4, 5, 6. Okay? But again, Johnson can say, no, myself, I have to consider, okay, this is fluorine. I have to consider alphabetical order. E and F. We start in the alphabetical order. F. Is it F or E? E. E then followed by what? By F. So if you follow the concepts of alphabetical order and not the positions of the substantive group, then we can say 1, 2, 3, 4, 5. But that will be wrong completely. Why? What will be wrong completely? Because the concept or the option or the truth of alphabetical order of the least dominant substantive group we will take it in account if the 2 less dominant substantive group are in the same position, means that and are in the same positions in terms of compare in reference or with respect to what most dominant substantive group. Listen, students, stop writing. Listen, this is confusing stuff. There you have only 2 answers, but the correct answer is 1. You know that even in my choice, the issue is the answers are there. The correct answer is there, but now to identify is another thing. Right?
Yes.
Listen. For example, if you have a benzene, listen, my dear student. Listen, let me reveal this concept. I hear the Lord speaking in my heart that open their mind to see and enjoy. You see, for example, you have this compound like this. That's the same compound. And here we have our most dominant substance, And here we have fluorine, right? And here also we have Si, CH2, CH3. For this case, with respect to most dominant substantive group, these two less dominant substantive group are in equal distance from this one. Are we together? So the issue, the factor of the position, the factor of positions for this case is the same. Why? Because this one is attached on the second carbon in reference to this one, and this one is attached in the second carbon in reference to this. Right? So for this case, you have to go into the second category. That in order to number the carbons atom on the benzene ring correctly and have a unique response, then you have to consider which less dominant substantive group has initial letter starting in alphabetical order. What does it mean? The correct answer for this case will be 1, 2, 3, 4, 5, 6. Why? This is Si. So we have E. This is fluoro. We have F. In alphabetical order. Is E starting before F or F starting before E? E starting, right? So this way, all the students, they have to number this way worldwide. Are we together? Because in this case, there is no contradiction that, this substantive group is a little bit far from the most dominant group. Okay? So for example, if I change this acyl to here, so the acyl group now is far from the most substantive group. So because it's far from the most substantive group, now if I take consideration, I take into account the concept of the positions where the less dominant substantive group are attached in, this is far from this, while this is closer from this. Right? So the numbering, because of the position, this is attached in the second carbon, this is attached in the third carbon. Because of the position, the numbering should not go in this way because we don't take the factor of alphabetical letters before examining the positions of the less dominant substantive group. So the first one is the position with reference to what? The most dominant substantive group. For that case, my dear student, the numbering here will be 1, 2, 3, 4, 5, 6. Why? Because fluorine is closer to methanoic acid compared to Si. There are the only two answers there. For if you have understood and you want to use the rule, there are the only two answers there.
Yes.
And sometimes you can do common mistakes in naming these compounds because you cannot notice sometimes. Maybe you notice outside of the exam. That's why I'm giving you practice, intensive practice, because this is the preparation for the next match that will be your exam. And always, even in sport, the time for preparing for a single match of 90 minutes and the cost that teams used to invest is much rather than even the time that they are going to play for the 90 minutes. But the more you invest in exercise, in preparation for the team, the more investment is done, the more practices are done, the more coaching is done, then winning is guaranteed. However, in Tanzania, sometimes people, they are going to the witch doctors to make sure that they win the match. No, that is African culture. It's not something confidential, it's known. But now when they meet with some of the maybe European teams, then you find that the trick or the technique fails because those guys, they used to play with fact because this is the ball. Okay. Because sometimes they can, you know that if you go to the spiritual, just we call them spiritual doctors or witch doctors or astrologers, sometimes they used to weaken you. They don't used to maybe to make the ball to be pushed towards on another team, just they get weakened. But depends on the face of other people or other players of the other match, of the other team. Okay, that's just like we call it break, just like a short break. Okay, so how do we name this compound now? So you have to follow the rule. We have named the less dominant substantive group. Okay, we have fluoro, we have SI. All together, which is starting alphabet?
SI.
SI. So it will be 5 SI. In case of writing the name, you follow the alphabetical order. In case of numbering, you follow the positions of less dominant substantive group. It's something you might think it is simple, but after 6 months, communicate with me and give me the feedback, a little clue about this. You'll tell me that, yeah, sir, what you are telling us is the truth. Then hyphen, we have what? 2. Tuoti, fluoro. Fluoroti, followed by the odiot, benzene. Then what the names of the substantive group, of the most dominant substantive group, it is what? Mesanoic acid. Tell your neighbor, this is the beauty of nomenclature of benzene. Some other students, they used to assume, because I know the nomenclature of alkane, so I'll be using the same rules to name other hydrocarbons compounds. And we tell you, okay, there's no problem, we'll meet with you on spot. If you have any question about example 6, please let me know in the comment section below. This is the example 7. This is extremely concept now. I want to give you some trick questions because at least that now I've been giving you milk. Let me give you at least a solid food. Name the following aromatic, organic compounds. Sulfonic. Roman 3.
Sana. Anachemeka wewe lenga. Unaona ndugu yako alichokifanya?
gave you this question as a homework, but none of the students who have tried even to think outside the box. I had 4 local students who have been joining me in different sessions, in all sessions of organic. When I asked them the feedback, they gave me a story. Do this minor correction. So at least now you are growing up in nomenclature of organic compounds. At least that so growing up. Okay, so we have a question named the following aromatic organic compounds. We have Roman 1, Roman 2, Roman 3, Roman 4. Roman 1, I have left the homework for you. For solution. And you're allowed also to try to name all of these compounds. Pause the video and then try to name all of these compounds on your rough paper. And then keep playing to watch the video and see the correction. So to notice how far are you from the truth of this nomenclature. So Roman 1, so this is homework code. This is homework code, homework 4. Roman 2, we have that compound. So we have this compound. So we follow the 3 rules that I told you. The first rule, identify the most dominant substantive group, or the most dominant substantive group here. This is sulfonic acid, right? We have. Then the second rule, number the carbon starting from what? From the carbon that carries what in the most dominant substantive group. Here is the carbon. We have 2 directions. So which one should we prefer? Always you prefer the directions which contains less number of carbons that attaches to the substantive group. If you go these directions, so I want you to understand 1, 2, 3, 4. So this substantive group is very close from this most dominant substantive group, right? So this is not correct direction. So the correct direction should be 1, 2, 3, 4, 5, 6. The first challenge is numbering. The first challenge is what? Numbering the carbon atoms. So now we go into the nomenclature of this compound. We have how many substantive group? We have how many less dominant substantive group? 3. This cyclopropyl and methyl. So for the cyclo compounds, if you want to know the first letter in the cyclo compounds, is not the word cyclo, it's common. The first letter for the cyclo compounds is the first initial letter of the name. What does it mean? Listen. For example, here we have cyclopropane. For example, then you have also cyclopropene. Right? And you have what is excuse me. Here we have cyclobutene. You have cyclopentene. Pentane. So if you examine these cyclo compounds, the initial letter that you have to check in alphabet is not C. It's the next letter after O. Okay? So here the next letter is P, here the next letter is B, here the next letter, it means that the standing letter is 2. Are we together? Are we together or you are confused? Okay. As they say that we do neither know if we are confused or we are not confused. God knows. Okay. So check the naming of these compounds, then you understand. So here we have what? We have this methyl, this cyclopropyl. So methyl starts with them. Cyclopropyl starts with P. Not C, because C is common for all cyclo compounds. Are we together? That's the trick I'm teaching you. Does M start from the alphabetical order or B?
M.
M. So if M starts, means you'll start with where does methyl attach in the carbon atoms? You can attach the first carbon. So for methyl hyphen, you have 3 because you have to name the less dominant substantive group. You have 3 cyclopropyl. Okay? Okay?
Yes.
You'll be challenged by your teacher. Why didn't you start with cyclo while he is starting C? You tell them, please, this is common. Cyclopropyl. This is the synonym, but because of the space, that's why I've been developed that time below. So the next way, according to the syntax, is benzene. Benzene, right? Then after writing benzene, we come to name the most dominant. Combinations of the most dominant. The most dominant is what? Sulfonic sulfonic acid. By the nomenclature. It's not simple the way you think. Nomenclature. I've been an expert since your level. Okay. Okay. We keep with that something we call it in English with read. You know the meaning of read? Read means keyboard. Endelea na keyboard hicho. Kusema nomenclature tu. Faster. Then here is another problem in our journey of learning nomenclature of organic compounds. Why? Because we have today a substantive group attached in another substantive group. When I gave my students to try this, they told me that, sir, seems like you're confused. There's no situation that you have a compound like this. And I told them, it's okay, fine. But focus on the truth. Okay. So the first rule, identify most dominant substantive group, which is methanoic acid. The second rule, number the carbon from the carbons that carry the most substantive group. And the third rule, name firstly the less dominant substantive group, followed by what? The word benzene, followed by the what? The name of the most dominant substantive group. Right? 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 Okay. So, okay, let me write it here because we need some space to do it. You have to make sure that you review this information. So here we have the methanoic acid. Then here we have nitro. This is more substantive groups. Then number this direction, you see that all the factors are attracting them. So 1, 2. Okay. But again, we have also another substantive group. It's dealt with the SI. So, we have this. We have nitro and SI. Which one are going to start? Alphabetical order. Pardon? Okay, we want now to study more about that compound. What should we do? So we have a cyclopropyl that attached in the first carbon of Si. We have dealt with it. So we have numbered the carbon atoms. That this is 1, 2, 1, 2, 3, 4, etc. Okay. So if that's the case, we start with SL always. Because here, the alphabet, the first letter of the substrate group is E. Here, the first letter of nitro group is the, yes, here, we say that this is SA. This guy will have nitro. So E and N, they are partly separated. Are we together? This one is SA. This one is alcohol. And of alcohol. So 1, 2, 3. Okay? Okay. 1, 2, 3, 4. But this SL group now, it is another substantive group, which is called what? Cyclopropyl. Say cyclopropyl. Say cyclopropyl. Okay. So listen. Here I do have SL. Just finding the simple language for you to understand. And here I do have carbon. I have hydrocarbon R. Okay? And here it is bonded with what? With carbon. Okay?
Yes.
Guys, are we together?
Yes.
Then here we have another substantive group. Okay? Okay.
Yes.
So then we want to think about this. So to think about this become its parent chain. This becomes substantive group. So this one will be 1, 2. So your cyclic compounds is in 1. So it is able to receive the rewards. Okay. So the first in alphabetical order between this and this is SI. Where does SI attach to? Hyphen. Then open the bracket. This is question 3, yeah? Huh?
Yes.
You don't know the number of questions. Okay, so listen. The way we name this cyclopropyl group, A.
Yes.
So we name this cyclopropyl group, we have to number its parent chain, which is this SI, right? So you have what? 1. So we write 2, which is carrying what? SI. But inside the 2, inside the SI, there's another organic compound. So for that case, that's why I wrote 2, I wrote dash, I put this open parentheses. Don't think that I'm playing. So this one, we said that we have a substitute group attached in a C. It's called a cyclo. Cycloty. Cyclopropyl. Cyclopropyl. Cyclopropyl what? This cyclopropyl attached in SI. Attached in what? In SI. Listen. SI is a substituent group of benzene. Cyclopropyl is a substituent group of SI. So this is the grandparent, this is the father, this is the child. Thank you. That concept will be easy for you. How do we write? This is the style. So write that the positions of the carbon carrying the substantive group, which is second carbon. Then we underline, then we open bracket. We name now that the child is called cyclopropyl. Then now what? The father is called what? SI. So we close the bracket to indicate that this is the naming specifically for this part. Then we still have what? A name. It's what? So if you number, it's 1, 2, 3, 4. It's 4. So in the first carbon, you have what? Nitro. Nitro what? We are going to name the substantive group. Then you have in the word what? Nitrobenzene. Nitro into what? Nitrobenzene. Okay? Fine. So if nitrobenzene, what do you still have?
Methanate.
So methanate
Acid.
Methanolic acid. Add a name. So you can find that now you are growing up. You go for 1-4. Give me the nomenclature of 1-4. All of you. Mike. Mike 40. Can you answer it? Can you answer this compound?
Yes, we try.
You tried.
Yeah.
But But you're not sure. Okay, let us. You can also try on the rough paper and we check the correct solution. So we say that here, the first step, identify what the most substantive group. Is there?
Yes.
What is it?
Sulfanoid.
Yes. Next step, number the carbon from carbon to okay, so then we have this not benzene here, it's the attached group.
Yeah.
So this is the substantive group. Then we have cycle. Okay?
Yeah.
Okay, so this is common for two substantive group, two less dominant substantive group. You know that this is stands for R. Okay, because R is represent hydrocarbons and this is sulfonic acid. Numbering starts from here to here to here. Let us write what less dominant substantive group followed by benzene, followed by the number 40 most dominant substantive group. This is cyclobutane, this is phenyl. Between P and B, which will start?
B.
B, yeah?
Yes.
I didn't mention B. Don't know where did you get B. So there we have 43 hyphen cyclobutane. 3 hyphen cyclobutane.
No, sir. It is.
Then we have what? 1 phenyl. Then now we have the name. So 3 cyclobutyl, hyphen 1 phenyl, then we summary twist.
We have to start from the most dominated carbon.
Okay, excuse me. This is 1, we have 2 options. Should we go this way or this way?
The one here.
Why? 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 I'm asking a question why? Or you don't know why?
Yes.
What do you know? So this is our sulfonic key. Let me just write it here. Okay,
Yes.
this is mostly substantive group. So you have to number the carbon from here, either this way or this way. So the point where we expect to have interactions of the bond is between sulfonic acid and benzene because of the reactivity. For that case that if you number this is 1, this is 2, this is 3, this is 4, this is 5, this is 6.
Yeah.
Are we together?
Yeah.
Okay. So if that's the case, then we go to alphabetical. B start before P. So this is called what? 6. So 6 is cyclo. 6 cyclobutane. 6 is cyclobutane. 6 is cyclobutane hyphen. We have 2 phenyl. Six cyclobutane, 2 phenyl. 2 phenyl benzene. Then our sulfonic acid est. This is our dominant substitute group. Okay?
Yes.
Okay, so that is all about nomenclature of benzene with more than one substantive group and contain the most substantive. Let me teach you the last part for this session, which is rules of nomenclature of benzene with more than one substantive group, or we call it without dominant, without the most dominant substantive group. How do we name it? Simple. Within 10 minutes, I will have finished the session. Rules of nomenclature of benzene. This is a very interesting class. Just nomenclature, that's very challenging. Nomenclature without most dominant group. Okay. So say that if the most dominant substituent group, does not appear in benzene group, then name the non-dominant substituent group alphabetically. Name them alphabetically. alphabetically and end up with the word benzene. End up with the word benzene. If you don't write today, when are you going to write? Okay. So you write at school, eh? Good. So if the most dominant substantive group does not appear, so it's no longer there, it's not there. In benzene, then name the non-dominant substitutive groups alphabetically. And then end up with the word dirty benzene. That's the rule. As a single rule. Example. Example 7 or 8. So you had 5, 6, 7. I think this is 8. You students write down this information. Don't watch me at the comment. I'm not doing comedy here. Name the following aromatic organic compounds. Name the following aromatic organic compounds. The first one is this. This is benzene with more than one substituent group. Methyl, nitro, you have bromo. Okay, so let us name that, then I'll leave example 9 at the homework to be the end of session 4. So the rules state that if the most dominant substantive group does not appear in the benzene ring, then name the non-dominant substantive group alphabetically and end up with the word benzene. So that's how the rule states. So, the first step, you have to check, identify. You have to check if there is, so you have to check by inspection. Does the aromatic compounds contains the most substantive group? The answer is no. So what should I do? So it means that the summary of this rule, we say that we have name of what? Name of non-dominant substituted group plus what? Plus the word benzene. So for Roman 1, these aromatic compounds does not contain what? Does not contain any substantive group. We can name it in two ways. You can decide whether to number it from here to 3 or the other way around. You can start 1, 2, 3 or 1, 2, 3, but not 1, 2, 3, 4, 5. That's wrong. Here you have 3 possible responses. To number from 1 to 3 or number from 1 to 3. The third possibility to number from 1, 2, 3, 4, 5, 6. The fourth possibility from number 1, 2, 3, 4, 5, 6. However, two possibilities are equal, so you can calculate as one possibility. So the aromatic compounds for Roman 1 does not contain any most dominant substantive group. So how do we name it? So you can name it as 1, 2, because comma separate numbers. 1, 3. Then what? Dimethyl. We have 2. Dimethyl what? Dimethyl benzene. That's the first name. Or the second name. We can call it what? We can call it that if we consider that this one to be a permanent odd, this means that a highly attached group to the benzene. So these compounds now becomes, we say, benzene or toluene. So it will be toluene with single substantive group. So the second name for this compound can say that is what? So if it's toluene, we find that this is functional carbon 1, 2, 3. So let's say this is 3 methyl. So 3 methyl, 3 methyl, 3 methyl toluene. So you have two names and should be familiar with both names. Roman 2. Roman 2, do you have any substantive group there? No. No, do you have any most dominant group? Most dominant substantive group? The answer is no. You have what? Non-dominant substantive group. How many are there? 1, 2, 3. So numbering, we choose. And always we start or we check the alphabetical arrangement. This is bromo, this is nitro, this is methyl. So B starts, followed by M, followed by what? N. So the numbering, we say that this is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. So this one we say that 1 bromo hyphen 4 methyl hyphen 3 nitro benzene. Here it is, Roman 3. Roman 3, we have what? We don't have the most dominant group. There's no most dominant group. So because we don't have most dominant group, then we have only non-dominant group. So we have to number, starting from priority, the first substantive group in alphabetical order. So here we have fluoro, hydroxyl, chloro. Right?
Yes.
So chloro will start. So chloro will start, one, usual, okay, chloro, it means fluorine is far from chloro, but hydroxyl is near to the chloro. Near to the chloro. So this will be the preferred direction. If you prefer this one, it means that finding fluoro in the first 1, 2, 3, 4, in the first carbon, it's a little bit challenging. So Roman 3, we say that we have 1 chloro hyphen what? 4 fluoro hyphen what? 2 hydroxy benzene. Or just don't try it. One day you remember. You get a cost. Or equality. Or sometimes you can treat these compounds as this one. It means with hydroxyl, we can treat it as derivatives of benzene. Right?
Yes.
So what the names of the derivatives of benzene, which have two substances, which chlorine and fluorine, is phenol. So you can call it a 1 chloro hyphen 4 1. Okay, then you have what? Fluoro, not fluoro, fluoro. Then fluoro, phenol. Fluorophenol. Okay, so ladies and gentlemen, let me end this session by leaving the homework. It has been very interesting, long session, but interesting. I believe that it has transformed your life. I have some of my physical students here who are in strike of writing the information I'm writing for them. So congratulations, keep on being in strike. For we don't have an options of being in strike. Name the following aromatic hydrocarbons. Okay, so these are the 3 questions that you have to make sure that you try your level best in order for you to be competent with nomenclature of aromatic hydrocarbon. I know that some students, because they have never possible that meet with these kinds of the 3 questions, they may say that Olenjolai is complicating. Actually, the nomenclature for benzene is not difficult, like the way that he has been teaching you. I didn't discover anything about aromatic benzene. What I'm just doing is to make sure that I teach you right things according to syllabus. So this is the end of session 4. Make sure that you do the homework, make sure that you review it. If you found that maybe you've got tired, make sure that you watch this video several times as you can. And before I end the sessions, I would like to take this opportunity to welcome you also into our Tanzania online advanced bookstore, where you can order different books that will teach about advanced chemistry, different notes, and also original scientific calculator. This is a very interesting interactive bookstore with affordable materials, because we like to equip our students with materials. So these are just the samples of materials that you may order in our online school or in our online labs. This is called conceptual chemistry. This is an exercise book that contains notes for the organic. This is advanced chemistry 1 review, and this is advanced chemistry syllabus for advanced secondary education for 5 to Form 6. So this is the original scientific calculator, Casio function 991 MS. So you may order these resources simply by sending an SMS to this telephone number 0759745331. Second, you may also use this telephone number 0759745331 or the bank account to offer your free Thanksgiving to our living God through this program. We are here not just after that to encourage you to do it, to do so, but we are here actually to open the gates, because sometimes that you can have, or you feel something in your mind, but you don't know if it's right. It's right. You may offer your free Thanksgiving through this telephone number, and to be used to pay for the running costing of unproduced or unrecorded sessions about advanced chemistry, advanced physics, advanced mathematics, and basic applied mathematics, in order to impact the life of present and future generation. So, my dear students, this is the end of our today's session. Join me in the next session, which will be session 5, where I will teach you about the chemical reactions of benzene. And the chemical reactions of benzene, we are categorized into electrophilic substitution reactions. That's what we'll be learning. And in the next sessions, also benzene undergo other reaction rather than what the electrophilic substitution reaction. So the next session will be about all the chemical reactions of benzene, and even the session 6 will be about the chemical reactions of benzene, and that's what will be continuing until we reach the activator and the activators and some other stuff. So be an active student, follow along, ask a question in the comment section, don't give up, don't panic. We are here to help you and not to destroy you. We are here to help you understand advanced chemistry. Should not worry, should not panic, should not give up. This is the world of organic chemistry. So because we had an opening prayer and God has done a great thing to me and even to you, let us have Omega prayer or Thanksgiving prayer. Our Father who is in heaven, we come before your presence. We say thank you for this opportunity. Thank you for the teaching that you have taught us today. Thank you for your greatness, and thank you for the greatest name that you have been given, or you have it, and we call it and believe and trust in it. Our Father in heaven, who is in heaven, thank you for giving me the fresh revelation anointing for session 4, and also you gave me the teaching anointing of session 4, which is titled as Nomeclature of Benzene. And this is the primary activity that we gave our forefather Adam in the Garden of Eden. And we thank you because even ourselves, the mankind and the scientists are still doing it. I give you all the glory and honor. I join to all my students to give you all the glory and honor because it's you who has been teaching through me. I'm just your donkey and I don't deserve any praise, any glory, anything else, any exaltations. But all the students that will see this work, they'll give you all the glory because they know it's beyond the human understanding. Thank you, my Lord. Thank you because you distribute this session to millions of students in advanced secondary education. Thank you because you love me. Thank you because you love my students. And Father, bless us abundantly in the world of chemistry, in the world of science, in the world of mathematics, in order for us to be the blessing to others. In Jesus' name, amen.
Amen.
So, thank you very much. May God bless you. See you in the next session. Keep enjoying the beauty of advanced chemistry for the rest of your life. Stay tuned.